Hi, my name is Tobias Kaup. I'm a robotics professor and the director of the Center Robotics here in Schweinfurt. The center has been up and running now for a couple of years, and we offer a bachelor course in both German and English, in robotics of course. We are also doing applied research together with the regional industry, for example Fresenius Medical Care, ZF Friedrichshafen AG or Linde Material Handling. We are here in our robotics lab, where we've been preparing for this year's Robothon challenge, and we hope we will do as well as we did last year. We're looking forward to it.
Hello, this is Hassan Mohammed again. I'm the team captain of the team RoboPig. This is my new teammates, Maximilian, Osama, and Florian. We study here in FHVS. We study mechatronics, electrical engineering, and robotics. We are really looking forward to compete in this competition, and we are ready to go. Now we will describe the hardware setup of our solution. So we're using the UR5E robot with the hand e-grabber, and also we printed the customized jaws, and we're using the Asha Kinect camera with some external light. So this is for the first task. For the second task, we're using the calculator, an additional tool to open the socket, and a place to sort the batteries. Now we will switch to the software architecture. So we have the laptop as the main station. In the laptop, we're using the Robothon software with Python script, and we're using many libraries like the Asha Kinect camera library and the Robothon library and robotics library. The Asha Kinect camera is connected with the laptop through USB, and we're receiving the RGB data and the depth data. Then the laptop is connected with the UR5E through the Ethernet cable. We're sending the move-J and move-L command, also with the UR script, and we're receiving the joint poses and the IO state of the robot. Inside the UR5E, we have the motion planning and the force sensing for the spiral surge. And the UR is communicating with the robotic hand e-grabber through the IO coupling. So now more details about how we solved our biggest problem. So the first problem we had a delay in the communication of the grabber, and we solved this problem by using the IO coupling. The second problem, we had a problem with the black stripes, and by using the morphology and the convex hull algorithm, we were able to cut out the stripes from the image, and now we can find the center point and the orientation of the task board. Also, with our new design of the grabber, we can now automatically center the battery inside the grabber, but we still have the spiral surge as a backup. Also, in this year, we have a new prism that can hold additional tools in our grabber. Okay, so now we want to talk about our solution for the transferability task and the impact it has in the e-waste problem. Germany is one of the largest producers of e-waste in the world. Every German produces around 19 to 20 kilograms of electronic waste every year. Of this, only 36% is recycled, with the rest is ending up in landfills, often in developing countries. In order to solve this problem, the EU introduced the Electro G3 law, so that every manufacturer of electronic waste must offer their customer a solution to easily return all devices and design them in such a way that you can easily remove the batteries. This law will come into force on the 1st of January 2022. This is where our solution comes into play. We have developed an algorithm that can detect a selected device with only a few features from a camera image and find its orientation and the position of the device. You can then easily open the suitcase with a robot. The camera allows you to see if there is still a battery inside and even what type of battery it is. The robot disassembles them again and sorts them according to the battery type. We offer a solution that can easily be adapted by industry specialists to their own devices. With our solution, manufacturers of electronic devices can do the task of disassembling their device themselves without a human handling old, sometimes dangerous batteries. In this way, producers can take advantage of the treasure hidden in their own devices, reuse parts, and take a step toward the circular economy.